Okay. So, hello everyone. I think it's already 7:12 and we have waited enough for others to join and many of us have already joined. So let's start the session now. So what I will do, I will share my screen now. Okay, I think my screen is visible and I'm audible to you all. So if you have any difficulty, there is this in-call message or you can just write it down here. And I encourage free questions. So in between, if I am teaching something, so if there is any question, please feel free to write it down here. And my major emphasis will be to solve the numerical questions because most of you are getting some problems in solving the numerical questions. And I want you to actually focus more on numericals. But one thing you need to understand that unless you get a good grasp of theory person, how those formulas are actually derived, you won't be able to approach the numerical question in a pretty better way. Okay, so this is the main problem here. Okay, so let me share my slides. So So once again, welcome you all to this NPTEL live session. This is Solar Energy Engineering and Technology live session 9 conducted on it's not 18th, I think it's 25th of September. This course is taught by Professor Pankaj Kalita and I'm the Rohit. I'll be taking live session. So these are the assignment questions from previous run of this course. So I won't be going through this. First we'll talk about some of the theoretical concepts, not all of them. I know that uh, professor has very beautifully explained the theory portion and those videos are excellent. So I will recommend every one of you to go through those videos and then we'll have a major focus on this the questions which we approach, so we will solve those questions. Okay, and then after solving those questions I will try to uh, take these assignment questions, and if there are any issue then we'll discuss accordingly. Okay, so let me share slides. So this is how we has actually discuss the solar air heater concept. So I won't go into this what is solar air heater, that you can easily go through the slides and videos. Advantages, disadvantages are not so important. Okay, so this is the concept. This is the basic concept which you need to understand, and then how this diagram is drawn. So if you have gone through previous lectures, you can easily find out how this is. This is basically a resistant diagram for heat flow. Okay, and this is how the energy balance for absorber plate and bottom plate, energy balance for air stream, all these are done, and then after writing those energy balance you can actually solve those equations to get the values. So I think most probably you won't be asked this much in the exam because it's a objective question based exam. So try to remember the important formula, like what is the pressure drop, like 4FLV rho V square upon 2D. So similarly for this, and let me move directly to the numerical question. So, okay, so I will copy this numerical question and I will solve this numerical question in front of you with changed values. Okay, so that will help you a lot. So let's put this numerical here. Okay, and see, I'm trying to approach this question, so don't panic. I'm trying to approach this question and try to solve it in front of you. So let's change some of the values from here, like let's make it 38. Okay, Okay, so these values are actually I can solve it with this values also, but I wanted to change these values so that you can feel it as a new how to approach a question. This is the main thing that is required for us. Okay, so let's make it 544. Let's make it 145 something. Okay, and the rest of things you can change as it is. So it doesn't matter whether you change or not change. Let's make it 38. Okay, so now let's try to solve this question. So the first thing which you need to do is to write down the given thing which is given values. Okay, so just write it here. What is given in the question? So first thing is given, the location data is given. Okay, so you can go back. The location is given 28.35. So you have been given locations. So convert it to degrees. So location is given, and I will make sure you guys solve this question. So I will change the values again, and then I will ask you guys to solve it. So it was 28 degrees and 35 minutes. So how do you convert minutes to degrees? Divide it by 60. Okay, and dividing it by 60, you will get something around. Where is the calculator? 28.35 upon 60 is something around 58 or something. Okay. Okay, this you got. The second thing is that you have been given global hour and another. So IG value is given. This is ID value, diffuse radiation. So you need to calculate the beam radiation. So what is beam radiation? Okay. So it is 544 minus 145. That is equal to, can anyone say me how much is it? Is it equal to 399? Okay, so 14 minus 5 is 9, then again 14, 13 minus 4 is 9, and then 4 minus 1 is, try to write the units correctly. So now this is given. Now another thing is that you have been given airflow rate, that is 38. Okay, that will also be needed. So first thing is that uh, let's uh, the first thing which you can do is, this is given, this 38 meter cube hour per meter square is given. Somebody wants to join. We yes. Akhil has actually said explain the topic, sir. Akhil, do you want to say something? Am I audible? And anyone else wanted to join? No. Okay. Now the first thing is that key you need to write the efficiency. So basically, it is demanding calculate the efficiency of a vertical south-facing UTC. Okay, and UTC and glazed transparent corrector. So that is so efficiency is basically uh, QU. I won't say it's a big Q. It's well, I did as it is at into area. So what is Q? Q is basically MCP del T, M into CP into del T, and you can write it IT as it is and then divide the A here. So mass upon area you can calculate separately. It has already been given 36 meter cube upon. Hello, sir, voice not audible. Uh, hello, am I audible? Oh, am I audible now? Okay, so yeah, let's solve this question. So where were we? We were this M upon A. So one thing is that key when we were trying to somebody wants to join. Okay, so one thing which I was telling is that when you try to approach a question, you need to first understand what are the given data in the question. So this is the main issue. So identify the data and try to make the data in the form in which you can actually utilize it for your purposes. So basically, here it is given that your data is basically m upon a value that you need to calculate. So m dot this is basically. So your data is given in uh, 36 or 38. I don't remember. It's 38. Okay. So I have changed the values of the numericals so that we can approach it in a fresh way. So first thing is that air flow rate is given in meter cube hour per meter square, but you don't need in you need it in perfect like kg per meter cube instead of meter cube you need it in kg. Okay, so how do you convert the meter cube into kg? So simply multiply it with density. So this is 38. Okay, so how much is the density of air? 1.2 kg per meter cube. Okay, So just multiply it 38 into 1.2. So this is something around 45.6. Okay, and this will be kg per hour meter square. So now the data is in kg per meter square. That is what you needed. Okay. Another thing is that key identify what is given here. So I think there's a empirical relation which is not copied here. That is something around del t varies as 0.03 IT plus 3.2. Okay, so this was a relation. Now mark it as one. Okay. So first thing is that if you needed del T is needed here. MCP del T, you know the CP of here, and this del T value is needed. IT you need to calculate. So IT also is demanded here and also is required here. So you need to calculate the IT. So for calculating IT, so first write the empirical relation so you guys don't get confused. Okay. So 0.03 IT plus 3. Okay. Now if you want to calculate the IT and mark it as equation 1. Now if you want to calculate the IT, so in previous lecture what you have seen, the formula of IT is IB into RB plus ID into RD. Okay. And then can anyone say what is after this? IB plus ID into RR. So mark it as equation 2. Okay, so this is equation 1 and this is equation 2. Now you know the IB value. Okay, IB is 399. You know the ID diffuse radiation value also 145. IB RD. Now you need to calculate the RB, RD and RR values. Okay, so how can you calculate it? So there are a specific relation to calculate them. Okay, so first thing is that you need to know the N, that is delta. So why do you need to know delta? So first thing is that you need to have this RB value. So RB equal to cos theta upon theta z, cos theta z. Another thing is that if you expand it, so it comes out to be sine delta. So you need to know the delta sine phi minus beta plus cos delta cos omega. Somebody wants to join cos phi minus beta upon, can anyone confirm me, sin phi sin delta plus cos phi cos delta and cos omega. Okay, so this is the value of RB, and then RD is 1 plus cos beta upon 2, and RR is rho, that is reflectivity, 1 minus cos beta. Okay, so every formula is you need to know RB, RD, and RR. Let me see if somebody wants to join. Get a new slide. Okay, okay. So when we were solving the question, so let me see if somebody has any question. Okay, no question. So now we know everything. You guys know. So first thing is that we need to calculate the delta. So how delta is calculated? Beta is beta is 90 degree for perpendicular this sun rays. But this omega is also given our angle. This is omega. Beta is 90. Omega is this, and phi is also given. Phi is this 28.58. So phi, this is phi. Omega we know 15. Beta we also know 90. The only thing we don't know is delta. So how delta is calculated? So you know the declination angle delta equal to 23.45 sine 360 upon 365 28 4 plus n. And what is n here? N is the number of days. So on which day we want to calculate? On 10th of December. So n will be, let's go to next slide. N will be, so start adding from 1st January. So January has 31 months, February has 28 months, and so on. Okay, so that will let's take a calculator and add it to be for 10th, then December at 10th month, sorry, 10th of day of December, that comes out to be 340 10 1 2 3 4 5 6 7 8 9 10. Okay, 344 days. So putting this value of n here, you get the value of delta. So put it here and tell me what is the value of delta. Let me put it here, n equal to 344. So delta equal to, so Akhil, I see this numerical is I am approaching step by step. So this will also make you understand the approach clearly, and also will help you in understanding the concepts also. So this is how we solve the numericals. Okay. So after putting this, take a calculator. Everyone take a calculator. 284 plus 344 into 360 upon 365. That is whole sine into 23.45. This comes out to be around minus 23.04. So now you have delta also. Write it here. Delta minus 23.04. Now you have delta, now you have phi from here, now you have beta, and everything you have. Now calculate me the RP, RD, and RR values. These are the formulas. Calculate it and inform me the values in the in call messages. Everything is on the screen. Did you guys calculate it? So, okay, so let me give you some more time if this is a big calculation. So, try to do it. This is quite easy, much easy, okay? So, the values are here only and you can easily calculate it. Okay, so were you guys able to do it? In between, I have also completed the calculation. Okay, no answers. Nishit and Vani. Okay, no problem. I will solve it. Okay. So yeah. So first thing, I just put the values here. We know the phi, omega. This is omega, not W. Okay, beta and delta. So I just put the values and has calculated. So RB comes out to be around something around 1.295. RD is around 0 0.5. RR comes out to be around 0 0.1. Okay, so just put the values, you will get this. So now put these values and get the value of IT. Put these values here. You know IB, ID, and RB, RD, RR. So IT comes out to be around 643 watt per meter square. Okay, so now you have IT, so you can calculate the del T. So del T is basically 0.03. Okay, what was that? 0.03 into, I also forgot. 0.03 into IT plus 3 into 643 plus 3. Okay, so this is, how much is this? With the calculator, 0.03 into 643, that is 19.29 plus 3. This is 22.29, and since it is temperature difference, so it is degree Celsius. So now you have everything for the efficiency formula. You know M by A, you know CP, you know del T, okay? You know IT. So just put it. Sorry, and I equal to, then you calculated the M by A to be something, where did you calculate? 45.6. 6. CP is 4.18 into 10 to the power 3 into this IT del T is 22.29. Then in below, what was that? IT. So you have calculated IT, and then A is basically here. So IT you have calculated, how much is this? 643. So another thing is that you have to multiply it with 3600. Why? Because this value is in kg per hour. Okay, see, kg per hour. So this is what is basically joule per second. So multiply it with 3600, so it will give for hour. So it comes out to be around 45.6 into 4.18 into 22.29 divided by 643 divided by 3600. So I think it's something 45.6 into 4.18 into 22.29 divided by 643. This is 44.21. Okay, okay. So what you needed to calculate this efficiency value. Okay, calculate the efficiency of vertical south facing UTC for the following data. So now you have got the answer. Okay, and you know the approach to numerical. You have approached this numerical, and you have solved this numerical. So after that we will move to this assignment questions. Okay, before taking some other numericals. So please feel free to ask any question if there are any. And also let me do one thing. Let me change the values here and give you. So let's duplicate this slide. So I will duplicate this slide. I will erase this. So let it be here. Let it erase. Erase. No erase. Okay. And I want to change this value to 48. Okay. Everything is. This is 38. Okay. Instead of December 10, let it be September for today 25. Now calculate me this efficiency. Okay, so I'm giving this question. I will wait for 5 to 10 minutes so you guys can calculate this, and then basically based on the previous approach I will try to explain how to solve this, and then we'll move to the assignment questions. Okay. Okay, so did you guys solve? Okay, so try to solve it as a practice question, and I will move next. I will try to discuss the assignment questions because those are actually also necessary. And if you want, you can take a screenshot of this. I think this was the question. Okay, so you can take a screenshot, and otherwise this video will be uploaded on YouTube, so you can follow it from there also. So now I will start solving the questions, assignment question. So I will give enough time to these assignment question. These are from the previous run of this course, but most assignment questions of current run are also very much similar to this nature. So if you guys can have a good idea, then you can easily be able to solve. So uh, I'll first discuss one question, then give a break so that you guys, if you have any question, you can ask. Then I'll go to next question. Okay. So the first question is provision of longitudinal surface in the air flow passage improves dash and dash of solar aerators. So actually, there is this airflow passage. Okay, so what it does, first thing is that it increases the collection efficiency. Another thing is that it increases the heat transfer coefficient. So the correct option is option A. So to give you a idea about how actual solar aerator looks like. Uh, Sorry, this is discard. This is solar. Okay, so to give you idea how the actual solar heater looks like, so it looks like this. So this is a blower. Air is actually passed through this, and then collected on that side. Okay. So if there are any questions you want to ask regarding this, so please feel free to ask. Okay, so should we move to the next question now? When vapor pressure exerted by moisture of a drying product equals the vapor pressure of air by ambient air, the moisture termed as. So it is basically equilibrium moisture. Because vapor pressure exerted by moisture in the drying product equals the vapor of the ambient air. So both are actually in equilibrium. So this is equilibrium moisture. Okay. Uh, Question 3. The ratio of partial vapor pressure of water in a solution to the standard partial pressure vapor of pure water is known as. This is basically water activity. So there was a portion also where professor actually teaches us about the water activity. So this is what it is. Okay. Then we move to the numerical portion. So yeah, we'll solve this numerical here. And first read this numerical, okay, then we'll try to solve it, then we'll have an approach to this numerical, okay. So this may seem to be a very heavy numerical, but it is not a heavy numerical. If you want, you can try it. So just try it, give it a try, okay. Otherwise I am here to solve it, don't worry, give it a try. I will solve it and I will show you how to obtain the convectivity transfer coefficient. So don't get fearful that questions are big or something. You can always approach this question and try to solve them. Okay, so that will help you actually to identify the process to solve this question, the way through which this can be approached. Okay, so let me see if any one of you has approached this question. Otherwise, I will solve it. No approach. Okay, so let me solve it for you guys. So first thing is that key I will need a blank slate. Sorry. So given is T1 and T2 is given. Okay. So first thing is you need to calculate the mean plate temperature. So Tm equal to T1 plus T2 upon 2. So it's given 27 is T1, 53 is T2, 1, 2. It's something around 40. Now convert this 40 to Kelvin. So that is around 313 Kelvin. Okay. Now the question is Ra cos beta. Okay. So how do you evaluate the Ra cos beta? Ra is basically Rayleigh number. Cos theta, not cos beta. Sorry. Cos theta. Oh, here it's written beta. Okay. So I will write as beta. Okay. So Rayleigh number is basically Grashoff's number into Prandtl number, and this cos beta will be as it is. Now, if you write the Grashoff's number, that is beta dash G del T. So please make a focus how I am trying to approach this question and trying to solve it. Okay. And kinematic viscosity, thermal diffusivity. So thermal diffusivity alpha, and then you have kinematic viscosity is cos beta. And how much is beta? Is 30 degree. So now at 40 degrees Celsius, the property is actually given. So just put these values there, and beta dash is 1 upon TPM. Okay, so that is 1 upon 313. Somebody wants to join. Let me see. Okay, so I was trying to solve the numerical questions from assignment, so you guys can know how to approach a question and try to solve it. So the question was this, and we identified the beta, we identified the TPM, then at 40 degrees C we have the values. So we are now calculating the Ra cos beta, okay? And based on this, we will use the possible solution. So you know beta dash is calculated 1 upon 313. You know G is 9.81 acceleration due to gravity. Del T is also known. Okay, how much is del T? That is 57 between the two plates. Temperature difference between the two plates here. 53 and 27. 53 minus 27. So if you want to be double sure about any mistakes, you can convert it into Kelvin. Otherwise, differences in Kelvin and degree Celsius are almost same. Okay. And L, you know, the value of L is given 0.20 mm. Okay, so it's 0.02. Alpha is given here. Alpha is given thermal diffusivity, and kinematic viscosity is also given. So just put the values 1 upon 3 upon 3 into 9.81 into 53 minus 27 into 0.02 whole cube. Now the big terms, that is 2.4 10 to the power minus 5 into 1.7 into 10 to the power minus 5, and cos beta is how much is beta? That is 30 degree. Okay, now calculate it how much it comes. So take your calculator out and 1313 into 53.27 into this. So it comes out to be around 1.8. Oh, sorry, not 1.8. 13837 something. Okay. So now with this value, please see here 1837. This will be here. Okay. This is between 5900 and 9.23 into 10 over 4. Okay. So we will use this expression of Nusselt number. So Nusselt number equal to 0.229 into RA cos beta, that is calculated above, to the power 0.252. Okay, this equation. Okay, now Nusselt number itself is HL upon K, and we put this value 0.229 into 13837 0.252. So putting the value here, this is L is 0. So remove this L and K from here. You need H only and multiply them here. So here K is, how much is thermal conductivity? 0.0272. And how much was L? 0.02. Now calculate it. Okay. So if we calculate it, is the calculator. So this is the calculator here. Okay. So 0.22913837127. This comes out to be around 3.34 or something. Okay. So now 3.34 is the answer for convective heat transfer coefficient, this one H. So the nearest answer is 3.32. So this is the correct answer. Okay, answer D. So please see this question and see the solution and try to visualize how this question has been solved. Okay, and let me check if there are any no questions. Okay, so I'll put this slide here so you guys can understand how this has been solved actually. So I'm sure you guys have a good understanding about this. Okay, so you guys are trying this question. So anything which you don't understand, please ask. Okay, I'm here to explain the steps. So if you feel anything which is not explained in the answers, and try to solve it by yourself also. So that will also help you a lot. So you guys could understand this. Okay. So please go through, make the same step. Otherwise, you can change the values also, and then you can approach this question. Okay. So I think this is a good question for you guys. So now let's move to the next question. So you have then given these properties, okay? You have given the dimensions also, and then you have given the Nusselt number. So you need to calculate the total rate of heat transfer from the zero plate. So this is another type of question which you can get in the exam. So now let me solve this also. So you guys can have a good idea about how to solve these questions. So I'm trying to solve each and every question so you guys can benefit from it. Okay. So first thing what you will do when you will approach this type of question, can anybody tell me? Yeah. So you will first see what data are given actually. So once you identify the data which are given, then you can easily try to put the formulas and get the answer. Okay. So this is how we solve a question. So first thing is given kinematic viscosity, thermal conductivity, specific heat, and thermal diffusivity. Okay. And air is moving at a velocity of 5 meters per second and temperature 27 degrees Celsius. We'll dimension this at 42 degrees Celsius. Okay. So this much data is given. Now you have to basically believe and identify how this can be done. Okay. So let's start this question, solving this question in front of you. At the same time, you guys also try to solve it. So if there are any mistake which you are committing, then it can be corrected. Okay. So let me do it for you. So let's start. So given, I will not write because a lot of things are given. So I will just start question. So you need to find the Q. Okay. This is you need to find. Now calculate the Reynolds number. So Reynolds number is needed, Prandtl number is needed. So that is V L 1 mu. Sorry. V is given 5, L is given 1.2, and then mu equal to 1.578 into 10 to the power minus 5. So how much is this? Please calculate. So mu value is taken from here. Please calculate how much is this. So this comes out to be around 380228.1 something. Okay. So you know the Reynolds number. Now the next thing is that you need to calculate the Prandtl number. Okay. Prandtl number is mu Cp upon K. So mu upon K is given kinematic viscosity mu Cp upon K. So we have kinematic viscosity given and this thermal conductivity or thermal diffusivity value is given. So thermal diffusivity is basically uh, upon rho. Okay. So we'll use these values to get the uh, this Prandtl number thing. Okay. So basically it will be this kinematic viscosity mu upon this thermal diffusivity alpha 1.578 into 10 to the power minus 5 upon 2.216 into 10 to the power minus 5. So this, okay, so this is Prandtl number. So now Nusselt number, which is equal to HL upon K 0.664 into Reynolds number power 2 Prandtl number power 0.664. How much is Reynolds number? 380 2 8.1 1 by 2 to this value. Okay, so let me write, but otherwise you guys can get confused also. So 1 point. So now you know the value of L and K. So erase it from here. It will be only H. Erase Nusselt number also from here. Now multiply this. How much is the value of K? 0.026. Okay, and then L is 1.2 from here. So this is something around, calculate it. Try to calculate it. So H is something around, is the calculator, 0.664 into 380 to 8.1 per 1 by 2, 1.57, then this cancels out. Okay, so this comes out to be around 7.92 watt per meter square Kelvin. Okay, now you have H. So Q is basically H into area into delta T, the temperature difference. You know H 7.92, you know A 1.2 into 1.2, that is area, length into breadth into, and delta is basically we have 27 degrees Celsius. Okay, and how much do we need? Let observer dimension is 42. So 42 minus 27. Okay, this is how we got. So 42 is observer temperature and 27 is air temperature. Calculate it. How much it is coming? 171.11. Okay, so let me write it clearly. Okay, so now 171 is the correct answer, answer D. Okay, so now you guys understood how to solve this question. Please see the slide to get a good idea. Okay, so should we move to the next question? I think the next question have already been discussed. Like this was the question IT and LT based question. So this one I think we have solved it here, na? It's the same question. Okay, so try to solve this question at home. Okay, so the for six the correct answer is basically 718 will be coming. Okay, and the efficiency will be something around 80.70. Okay, try to solve it. This based on the formula. I think I have solved it. So I think we have solved it actually in the starting of this live session. Okay, so this is also on the same pattern, same totally same pattern. Just you have to enter the values are given, all the values are given. The useful heat gain rate in the what is collected, so that will be 723.93 or something. Okay, so this is how you have to approach the question actually. So basically in this question I think you have to have find sorry you have to find the QU, that is useful heat gain. Then you have to find the temperature at the outlet, and then MS pressure drop. Okay, so you can easily calculate this question. This is not a very big thing. Just all the formulas are actually given. So just I will write the MS pressure formula here. So say 0.079 to Reynolds number to the power minus 0.25. So if you have calculated the Reynolds number, put it here, you will get the value, that is this one. Okay, or then this will be 69.685, be equal to this. Okay, so and then we have this 11. This is solar chimney based question, so I think this was actually solved also. So this is quite easy question. Let me solve it. Actually, the maximum possible efficiency. So maximum possible efficiency is basically GH upon CP into TA. So you know the value of G, that is 9.8, and height is given 240. When CP value is given, specific it 1007. Okay, so put it 1007 here, and then ambient temperature values, that is, so make sure this you put it in Kelvin. Okay, so that is 273.15 plus 27, so that is around where's the calculator, 9.81 into 240 divided by 1007 divided by 300. Okay, so this comes out to be around 0.779%. Okay, and 200% because it's efficiency. So this is so you can see the efficiency is very less for a solar chimney plant, less than 1% itself. So that is why these plants are not so successful. Still, it can produce a good volume of air or something. Okay, and the next question is daily electrical output from the chimney. So we just calculate the overall efficiency in collector efficiency will be there. Okay, collection efficiency. Then you multiply it with maximum efficiency, that is calculated here. Then you have transmission efficiency. Okay, so that we turbine generator efficiency, not transmission efficiency. So collector efficiency is 28%, 0.28 into 0.25. 0078 into 0.6. So this multiply these three, this will be around 0.0013. Okay. So overall efficiency, 1.3%. Okay. So collector output will be, so just calculate the total average solar radiation is 6.8 into this area is 42,000. Oh, what is happening? 6.8 into 42,000 into overall efficiency, that comes out to be around 0.0013 or something. Okay, so this will be multiplying all these 374.14 kilowatt hour. Okay, so the nearby answer is 373.85. Okay, so this you will solve at home. I have solved it. So I think I don't know how this is. Okay. So thank you all. Thank you for this session. So I think it was a knowledgeable session for you guys, and you got to learn a good concepts and numerical. I've tried to solve the numericals as per your uh, previous feedback. So I'm sure you guys will be able to solve this question when you will try to approach it. Okay. So thank you once again. So we will meet at next Monday. Thank you.